and how this the transforming engineering education relates to climate action. And as an output from the series, we will have a short report or guideline that summarizes all the different key points from discussions, but also case studies, technical presentations, resources. We want to make it available for those who are interested in the topic and they want to actually understand how engineering education can be transformed and what others are already doing. So next, today we have the pleasure to have a multilingual, I guess, session, and one of our presenters will present in Spanish. So I would encourage you to do this now. So these enable captions. So just click on the three dots on the bottom bar, three dots more, and then select captions, and then go to select your speaking language, and then just select the one that is most appropriate, and then select your caption language, which is in your case should be English if you're an English speaker. Right, Gemma. I'm messing this up. So next is just to show you where we are in the series. In fact, I have highlighted the wrong session. We're 2nd of October, mainstreaming sustainable development in engineering education, talking about key competencies and emerging topic areas. And then you can see the rest of the sessions. And then a quick one on to just frame the topic today. As I said last time, just also for those who were not there, this idea of transforming engineering education and to convene a learning hub around this topic comes from a key publication that ICSI launched almost exactly a year ago. And it was reviewing the global engineering capacity and capability. And one of the key findings from that was the need to quite quickly and quite at scale transform and adapt the engineering education to ensure that the future professionals are ready to tackle the challenges such as climate change, so resilience, nature crisis, and so forth. So one of the key things was that actually we reviewed the available frameworks and different definitions that were out there, or in terms of what knowledge do professionals or students need, what are the skills, what are the competencies, what is the relationship between all of these different concepts. And this is one of the available frameworks. What we found actually from that research and mapping everything, we found that there are many overlapping concepts and many overlapping frameworks, and that can be a little confusing. And so maybe next, just to give you just an idea of some of the available definition, and the one that we ended up sort of pointing people to as one that provides a bit more clarity, or a bit of clarity, is so you need knowledge, and the knowledge is the foundation, and these are the topics that you kind of teach and the learned material. And then you need skills that are learned abilities, and they are more specific to enable individual or students in this case to perform tasks or activities. So say an example for recurrent skills from the mapping that we did were data analysis, digital skills, collaboration, critical thinking, and so forth. Mindsets. So mindsets are more going more towards the social sciences and kind of what is the behavior, what's the emotional intelligence needed, and also the beliefs that are needed to actually enact certain, to perform certain tasks. And then the knowledge, skills, and mindsets, they kind of come together to create competencies. And so the ability to carry out engineering tasks successfully in the field of practice. So we're kind of moving from you're learning something, then you got skills, then you got mindset, and you build that competency to be able to do it in practice. But that also does require experience, because you, especially for those who are taught at university, then like you do need that kind of practical ground to just put that knowledge and the skills and the mindsets in practice. And then the values that are kind of more like it's just all encompassing, what's kind of what are the cultural principles that kind of like bring it all together. So that's kind of one way to look at things. But there are, as I said, many different frameworks out there, and they are a little bit overlapping. And I think probably today from Jonathan and Julian, we will hear examples of how they have actually built frameworks that can help. Next, please. So I'm now passing it over to Joe Price, who is technical coordinator and expert at the Resources and Markets branch at UN Environment Program. Joe, you online?
Yes, hi Sabina, hi everyone.
Hello. Okay, over to you, Joe. Thank you.
Yeah, thank you very much. So on behalf of UNEP, we're really pleased to be involved in this learning hub with our core IEL partners, ICSI and Duke. Thanks everyone for your interest in the topic. So at UNEP, IEL has been a key mechanism for our capacity building work on sustainable infrastructure over the last few years. And for us, our work is really framed by these international good practice principles for sustainable infrastructure, which I'll introduce briefly now. And as Savina mentioned, we held an initial pilot series of IEL sessions between 2021 and 2022, which were structured around these 10 principles. And they helped engineers, planners, policymakers, and other stakeholders to put the principles into practice. And we hope that the principles might be useful in informing the evolution of this learning hub, highlighting the key sustainability considerations to think about in relation to engineering curricula. So the principles essentially provide a guiding framework to integrate sustainability across the whole infrastructure lifecycle in alignment with the UN Sustainable Development Goals and other relevant global agendas. And they cover 10 guiding principles across environmental, social, and economic dimensions of sustainability. And on the slide, you can see them listed there. They start with early strategic planning and government, which is principle number 1. Ranging down through specific environmental aspects like investing in nature, which is in principle 4, and then resource efficiency and circularity, principle 5, but then also the important social dimensions like equity, inclusiveness, and empowerment, that's principle 6. And then finally, some of the economic topics like principle 7's enhancing economic benefits, which covers things like job creation and stimulating local businesses. So they really aim to cover all of the key considerations based on consultations with countries worldwide. So there's a really global perspective here that's drawing on all of the on-the-ground perspectives and priorities and values in countries around the world following consultations we did. So really looking forward to supporting this learning hub where we can, including via these principles, and always ready to help share case studies and good practices from around the world as well. So thanks again, and looking forward to the rest of the session.
Great, thank you, Joe. So this resource, it's been posted on the chat. The chat, we also have the resource that I mentioned, the ICSI Global Engineering Capacity Capability paper. So you can access them in the resources chat there. And now we want to just have a quick interaction with you guys in the audience. And we have a Mentimeter question for you. You can scan the QR code, I think, or you can visit menti.com and there is a code and there might be a link in the chat possibly. But the question for you there is what skills, competencies will be critical for engineers to respond to the climate crisis? Just as an initial sort of capturing what in people's mind, which we'll then discuss a little bit more in more detail in the breakouts. It's just warming you up on the topic. To the climate crisis as an example. Obviously, it's not only the climate crisis that we need to be dealing with. So if we could please, show the results. Just see what people. System thinking is definitely something that has come up so many times, and this is one of the things that when we reviewed all the competencies, skills, knowledge, mindsets, system thinking was that one thing that was overlapping. Something that really came out as that one. Whether it's a skill, whether it's a competence, or it just comes up as something super important. That should be part of our discussion. Designing for future scenarios, risk assessment, yes. Technical, but not just only technical. Yes, absolutely. Issue-based solution understanding, which is missing. We talked about this quite a bit last time. Yeah, some more risk assessment, stakeholder engagement, trade-offs. Yes, absolutely, trade-offs. I'm a big proponent of trade-offs and then communicating them transparently, clearly. System mapping, system thinking, yes. Understanding complexity, uncertainty, I'd say also probably. Great. Thank you. So that's a kind of a bit of a flavor for, I think, the topics that we will be discussing a little bit more in the breakouts later on. But without further ado, I'd like to just pass it on to our first presenter today. So Dr. Jonathan Truslove. He is Education and Skills Lead at Engineers Without Borders UK. So just reading quickly on your bio, you're an interdisciplinary researcher, which is, we just want to hear from you, like how you actually do this and what you've learned by doing this, a facilitator and a collaborator developing opportunities to learn about how to embed global responsibility at the heart of our engineering in thought and practice. So I know this is exactly the topic you're going to be talking to us about. So thank you, Jonathan, and over to you.
Lovely. Thank you very, very much. Good morning, good afternoon, good evening, wherever you're joining from today. It's a delight to speak to you as part of the second session in the learning series. Apologies as well for my voice, it's only just recovered today. But I'll be giving you an intro to our global responsibility competency compass and its role in pointing to the capabilities needed to stay relevant for our 21st century challenges. Next slide, please. So at Engineers Without Borders UK, we are working to reach the tipping point to where global responsibility becomes integral to the way that engineering is taught and practiced. And I've fired a link in the chat at what global responsibility is and what it means to us. It means that engineers must critically reflect on the role of engineering in society and understand the social, environmental, and economic impacts that it has. And as an organization, we are working to drive this change by focusing our efforts on two key pillars: engineering in both education and engineering in practice. Because we recognize that to ensure current and future engineers are equipped to address global challenges, they need the right knowledge, skills, and mindsets to be truly globally responsible in their practice. Next slide, please. Because people in all fields are now required to navigate greater complexity and uncertainty in addressing societal and ecological risks. And engineering has to be part of that response. But to do so effectively, it needs to embrace a broader role beyond its traditional focus on technical orientated skills. Engineers and non-engineers of today and tomorrow will be entering a world of increased complexity and uncertainty. From the climate emergency, each degree increased sees future and increased challenge. The biodiversity crisis, rapid technological changes, advancements in AI, and we are falling short on Sustainable Development Goals. We are at the midpoint of the decade of action, and there is no SDG that any country is on track to be delivering as a globe, as the global community. Next slide, please. So when thinking about global responsibility, some of you may be familiar with this visual. It has been updated this week, 2 days ago, so please have a look out for that. This is the donut economics model, and it's a useful tool to help visualize what we mean by global responsibility, essentially balancing the needs of all people within the limits of our planet. So this inner ring, this social foundation, is based on the Sustainable Development Goals. And this outer ring is the environmental ceiling, planetary boundaries, is based off of research from Johan Rockström. And when looking at the donut, it becomes clear how engineering plays a direct and indirect role in unjust and unsustainable use and facilitation of resources. So engineering's critical delivering the social foundation of housing that provides safety and security to people. To provide housing, we use the planet's resources, such as land, which can negatively impact biodiversity, water, which can impact freshwater withdrawals, and construction materials, such as concrete, is one of the largest carbon emitters in the world. So there is an urgency needed to accelerate more responsible practice because these challenges are inherently interconnected and complex, and success means focusing on improving these systems, not just solving these problems in isolation. Next slide, please. Therefore, we need the capabilities to be able to respond to this effectively. but there is a skills gap in the engineering sector. In practice, there have been studies over the last few years that suggest the skills gap to help drive the sustainable and net zero agendas are lacking, such as critical thinking and systems thinking. And when we look at the emerging generation of engineers, areas like the SDGs are still absent from education. But current students and graduates, many of whom will be in work now, want to be equipped to address these challenges and will seek out employers who place importance on tackling societal and environmental issues. Because when we think about engineering, if all engineering was remembering formulas, analyzing information, then we'll be designing software that will make us redundant. And in many areas, we've done just that. Next slide, please. And this is where the compass comes in. So the Global Responsibility Competency Compass points practitioners to the capabilities needed to stay relevant and provide practical ways to develop themselves. So the work of engineers requires highly technical expertise, but also the ability to creatively adapt to rapid changes in how we work and the challenges we're faced with also a deep understanding of the context we're working within and the needs and the values of the people we work with, those that our work will ultimately impact. So the compass is for practitioners from multiple disciplines working in engineering who are looking to respond effectively to the challenges of our age. So the way we frame the compass just so happens to be very similar to the way that knowledge, skills, mindsets, and values have been outlined by Savina at the start of the call. We have 4 guiding principles that we want to see adopted across the engineering community. And these are to be responsible, to meet the needs of all people within the limits of our planet, purposeful, to shape outcomes to be equitable and ethical throughout engineering and the life cycle of any project, inclusive, to ensure diverse viewpoints, knowledge are included in engineering process and outcomes, and regenerative, to maximize the ability of all living systems to achieve a healthier state and naturally co-evolve. Next slide, please. So the compass is made up of 12 competencies, a knowledge, a skill, and a mindset, each aligned to these principles of global responsibility. So it's not a competency framework, but a guide to those working in engineering. The compass is not intended to replace competency frameworks, but to overlay them with the competencies of global responsibility. So you have a competency framework that you adhere to either for your CPD, through your professional engineering institution, or through your own organization. The compass helps bring global responsibility to the forefront to unpack what that complexity and uncertainty looks like and provide clarity on what competencies are useful. So for individuals in multiple disciplines working in engineering, identify your strengths and any gaps that you need for your role. For teams, we don't expect everyone to be experts in global responsibility. So it's important to remember that teams need to reflect on their own strengths as a collective and value the contributions of diverse groups within their teams. And then for educators to support the development of motivated and committed teams, to demonstrate your responsibility as an employer and to help your staff meet and maintain professional qualifications. Next slide, please. So I mentioned that there's competency frameworks you might have to adhere to. One of the ways that the compass helps is that the compass is endorsed by the Engineering Council in the UK, which sets out the competence and commitment required for registration as a technician, an incorporate engineer, or a chartered engineer. So the compass is mapped to these dimensions of UK spec, and the Engineering Council is a signatory of the Dublin, Washington, and Sydney Accords. So there's a global interconnection there. So this can be used to help attain and retain professional qualifications, such as through, in the UK, the Institute of Civil Engineers, who also endorse this compass. So whoever you're associated with, the compass can help you bring global responsibility to the front. Next slide, please. So overall, you can use the compass to upskill yourself, a learning tool, identify your skills, and bring more global responsibility into your professional development. You can use the competencies to ask good questions to help you embed the principles in your day-to-day, such as like, what is the purpose of this work? What is the impact? You can place importance on the right things. How are you leading by example and regularly acting responsibly? Raise the bar on the professional competencies required from professionally qualified engineers. And sometimes the best thing you can do is be a bigger part of that call for change, because together our voice is louder. So imagine what type of culture and norm engineering might have, because more than any other time in human history, the future is ours to shape. Together we can have hope for a better, sustainable, and more equitable future in the best way that we can, because in short, why wouldn't you? Next slide, please. So just as I come into land, I'll talk quickly about how the compass relates into our work in higher education. So as well as our work and practice, the compass supports how we develop learning outcomes and assessments in higher education. So the competencies outlined in the compass are aligned and evidenced through the learning outcomes and assessment process of our in-curriculum design challenges. So on screen is an example of how we frame a knowledge, skill, and mindset into our educational offering. I'll share a link after the presentation to that article in full. Next slide, please. One of the examples in which we embed that learning journey through the compass is through our flagship program, the Engineering for People Design Challenge. So this brings to life real-world design challenges faced by local communities. So we work with a community partner each year to bring and develop our in-curriculum program, which we've been running since 2011. So we've reached about 100,000 students now since its inception. And it seeks to inspire multidisciplinary groups of students to broaden their awareness of social, environmental, and economic implications of engineering. So 91% have broadened their understanding of global responsibility. 83% feel confident about addressing the SDGs in their work, and 85% have increased their skills, such as in team working and project management. Next slide, please. But as well as our plug and play offering for curriculum, we also need systems-wide change in both educational institutions and that are preparing the engineers for the workforce and industry across the work that their work will be delivered. Another resource that we have, which the Compass aligns quite heavily with, is the Reimagined Degree Map. So this is intended to facilitate constructive conversations and engagement with a diverse group of people to navigate the decisions that are urgently required to prepare students for 21st century challenges, and essentially keeping curriculum relevant and embedding global responsibility for the education of the next generation of engineers. Next slide, please. So we have many supporting resources that are aligned to and support people in upskilling in the competencies outlined in the Compass. We have a learning library, which is a curated bank of practical learning to help build the knowledge, skills, and mindsets. Within the Compass itself, we have an action plan to reflect on how those competencies and what learning you might need to be embedded in your CPD. We have a self-assessment tool launching this year to help build your own awareness of your own strengths and any gaps in competencies needed to provide useful insights for your own development planning. And alongside adopting our Engineering for People into your curriculum, we have volunteer opportunities for practitioners to review the innovative design concepts to the student teams. So professionals provide written feedback to those student teams, and we know this is an opportunity for professionals to learn about global responsibility as much as it is for the students who go through this. So within this ecosystem of global responsibility resources, we're helping students and practitioners gain those skills, that knowledge and mindset, supporting educators as they themselves are upskilled in topics they might not have been exposed to in their education, and guiding leaders to shape the context and outcomes of engineering degree programs. Overall, it's a people-centered system, the education system. We're connecting people who are advocating and driving that systems change forward to embed this into how engineering is taught and practiced. So thank you so much for listening. I'm delighted my voice held up. If you're interested in any of the resources and opportunities I mentioned, you can find them on the screen here. They'll be in the chat. And please do not hesitate to get in touch in adopting them. My email is on the screen now. I look forward to your questions later on. Thank you.
Great. Thank you so much, Jonathan. And thank you for joining us with your voice just barely recovering. So thanks for that. And great presentation. And this is exactly what we want to do, is just make people aware of all the resources and all the different thinking that's gone into this already. And Engineers Without Borders obviously worked on this for a long time. So thank you for this. I know our next speaker, Julian, needs to leave quite early. Julian, when do you need to leave? Do you have time to stay a bit longer for your presentation? Yeah, I'm just worried that you will have no time.
No,
You're okay?
you
You
yes,
have
I am
time.
okay.
Okay, great. Okay, so
Yes.
then we will do another Menti question first, and then I'll pass it over to you. So this other Menti question is around more the emerging topic areas that are increasingly being integrated into engineering curricula. Perhaps not at the scale and pace that should be integrated, but this is kind of to surface some of them that will then be talked about in the breakouts. So if you'd like to interact with us on this and share your insights. Is this the same? No, it's next question. Okay, so some of them starting to, not yet. We had not moved on probably the Menti. So you should now be able to contribute. nature-based solutions, of course, that's absolutely how to include nature in engineering decision making more broadly. Project delivery. Okay, different approaches, I guess, to project delivery. Indigenous knowledge, yeah, how do we incorporate traditional knowledge? Yeah, carbon sequestration, nature-based solution for climate disaster mitigation. Social sciences, yes, absolutely need to social scientists teaching to engineers and probably vice versa, engineers getting involved in social sciences degrees at some point to share some of the technical principles, designing for resilience, alternative materials, yes, weak problems, yes, societal challenges, complexity, yes, social sciences and engineering. Great. Thank you guys. So this is kind of again giving us a little bit of a warm up for the group discussion, because we will want to just go a little bit deeper and try and maybe put a bit more context into how would what you know, what's the scope of the topic to be included, how could they be included, and so forth. But that's what we will do in the breakouts. And now I'll just switch to Spanish and let's test the caption. So voy a cambiar al español a ver si funcionan los subtítulos. Es un placer presentarles a Julián Cortés Ollero. ¿Ollero se pronuncia así? ¿Ollero? Julián, sí.
Sí, yeah.
Profesor de la Universidad de Chile e investigador intertransdisciplinario, ¿no? Interdisciplinario, transdisciplinario. Muchísimas gracias, Julián.
Mm.
Es todo un gusto tenerte aquí con nosotros. También nuestro primer ponente multilingüe, que lo hace aún más especial.
Ah,
¿Tienes la palabra, Julián?
okay, thank you, Sabina. Hello, everyone. Everyone, I would like to thank ICSI for inviting me to participate in this event. And I will like also like thank you all. My English isn't very good. I want my ideas to be well expressed. Then I will give my presentation in Spanish, but I will be happy to answer any question when the opportunity arises. I know that we Chileans have a reputation for speaking very quickly. So for sake of relation, I will try to speak slowly. Okay? Ok, ok, esta presentación, ¿sí? Explora de alguna manera cómo la educación en ingeniería debe evolucionar para responder a los desafíos globales actuales desde una mirada integral. Eh, por eso intentaré enfocarme en tres ejes estructurantes para que se pueda entender este tema, ¿sí? Por un lado, los Objetivos de Desarrollo Sostenible, que constituye el marco global para abordar las problemáticas sociales, ambientales y económicas de manera integral. Por otro lado, los enfoques inter y transdisciplinarios fundamentales para la comprensión y la actuación sobre sistemas complejos, es decir, aquellos que requieren un conocimiento diverso y una colaboración entre múltiples actores. Y finalmente, remitirme a los temas de las competencias básicas que las ingenieras y los ingenieros deben desarrollar para enfrentar estos retos con creatividad, y con creatividad, eso sin dejar de lado el rigor técnico, ética y sobre todo responsabilidad social y ambiental. Entonces, a lo largo de esta presentación, también quiero mostrarles algunas experiencias prácticas que hemos trabajado desde la Universidad de Chile, que de alguna manera intentan ejemplificar estos principios en acción, ¿sí? Y asimismo también mostrar cómo desde la Facultad de Ingeniería de la Universidad de Chile intentamos preparar a los futuros ingenieros como estos agentes de cambio con un compromiso fuerte, tanto ético como social, hacia la sostenibilidad global.
Julián, perdona, te interrumpo un
¿Sí?
segundo. Sí, no sé si la traducción funciona. Un segundo. Do you guys have captions?
Oh,
Does the audience have caption that work?
So, I've got captions, but it's just captioning the Spanish.
In
It's
Spanish, okay.
Same
Do we
here.
need to?
Spanish.
Okay.
Yeah, same here.
Okay, all right. Let's see if the technology can make it, do we need to set it up in a different way?
So I think, Julian, if you can just check your settings, if you click on captions and just make sure
Ah.
that your speaking language is set to Spanish.
mm. Ah, ok.
Let's try.
And-
Did you find
Sorry.
oh,
if you click
No.
the three dots where it says more, maybe I'll just go back to the translation side quickly.
Sorry, guys. We just, this is obviously the first time
Oh.
we do it. A bit of teething problems.
So if you just follow these instructions to change your captions. Can you see that setting?
Ujú.
Se ha encontrado, son 3 puntos en
Sí,
abajo,
sí, sí.
allí. Ujú. Tienes que cambiar tu idioma.
Ujú.
Speaking language
Puse
es español.
en español, sí.
Ujú.
Está,
Lo tenías en español.
sí.
Sí.
Ujú, sí.
Y caption,
Ah, I think it's
En
working
inglés.
now.
Ujú.
habla, ahora un segundo a ver si funciona.
Sí. Ahora aparecen los
Se
subtítulos.
aparecen en inglés, ¿no?
No, it's
Ujú.
perfect.
Ok, perfecto.
That's
Ok.
good.
Ah,
Thank you.
Ya está.
ok.
Perdona, ¿eh?
Don't worry. Eh, ¿Comienzo nuevamente o
Si puedes, si no te importa.
continúo? Sí, ningún problema.
Ujú.
Voy a entonces intentar resumir lo que estaba hablando. Les contaba que esta presentación entonces busca mostrar y explorar cómo la Universidad de Chile, particularmente la Facultad de Ingeniería, está intentando responder a estos desafíos globales para la transformación de sus estudiantes en estos ciudadanos y agentes de cambio que se necesitan para los desafíos globales que se vienen. Y en ese sentido, esta presentación estaba enfocado en tres ejes que de alguna manera constituyen, por un lado, los objetivos de desarrollo sostenible, que es el gran marco global para abordar estas problemáticas desde el punto de vista de la enseñanza, eh, la necesidad de incorporar enfoques inter y transdisciplinarios para la comprensión, por un lado, y por otro lado, la actuación sobre sistemas complejos, como son los desafíos que tenemos actualmente. Y en tercer lugar, articular esta presentación en torno a las competencias básicas que las ingenieras y los ingenieros deben desarrollar para enfrentar estos retos, por un lado, con creatividad, pero sin dejar de lado el rigor técnico y la responsabilidad ética y social que tienen. Entonces, para poder ilustrar esto, también les quiero mostrar 3 experiencias que hemos estado trabajando desde la Universidad de Chile en torno a mostrar cómo pretendemos o estamos en camino de formar a estos futuros ingenieros como esos agentes de cambio y agentes de cambio con, digamos, así, con un profundo compromiso con la sostenibilidad global. La próxima, por favor. Entonces, para ello, el primer punto, como les señalé, tiene que ver con el reconocimiento y el intento de integración de los objetivos de desarrollo sostenible dentro del currículum universitario. O sea, de alguna manera, lo que intentamos hacer, y es una discusión que llevamos de alguna manera 3 o 4 años ya trabajando, es cómo generamos las condiciones para que estos objetivos de desarrollo puedan integrarse a los currículum no solo de la ingeniería, sino que también a todo el currículum de manera transversal dentro de la universidad en la formación de estudiantes, sobre todo de pregrado, y bueno, con mayor énfasis también en estudiantes de posgrado para el desarrollo de tareas propias o relacionadas a la aplicación práctica y la investigación. Y en ese sentido, algunos de los ODS que orientan la formación, particularmente en ingeniería, son el ODS número 9 en torno a la infraestructura resiliente, el ODS número 13 respecto a la acción climática, por supuesto el ODS número 7 sobre energía asequible y limpia, y el ODS número 11 respecto a las ciudades sostenibles. Entonces, a través de la discusión que, como les comentaba, hemos estado llevando adelante, el objetivo es incorporar en la educación que se ofrece a las y los futuros ingenieros estos marcos para el diseño de soluciones tecnológicas que respeten las dimensiones sociales y ambientales de los problemas complejos a los cuales se van a ver enfrentados. Entonces, creemos de alguna manera que este alineamiento con los ODS fortalece la pertinencia social de la ingeniería y de alguna manera busca la promoción de una visión holística de los problemas donde se genere esta vinculación entre las competencias técnicas y los desafíos globales. La siguiente, por favor. Bien, en ese sentido, el otro eje estructurante, como les mencioné, tiene que ver con las aproximaciones o los enfoques inter y transdisciplinarios en la educación, en la formación de los estudiantes. Entonces, la complejidad de estos retos globales, de alguna manera, nos exigen este tipo de perspectivas más allá de la aproximación disciplinaria de alguna manera que la aproximación disciplinaria aislada, ¿sí? La interdisciplinariedad, por un lado, implica esta colaboración entre varias disciplinas académicas para integrar estos conocimientos, conocimientos distintos de distintas áreas y lograr una comprensión o una primera comprensión del problema. Ahora, ¿cuál es el problema que nos hemos encontrado con los enfoques interdisciplinarios? De alguna manera, uno de los grandes problemas tiene que ver o dice relación con, digamos así, la epistemología, ¿sí? De cómo están estructuradas las disciplinas, ¿sí? Y eso, y esta, digamos, este desafío epistemológico nos ha llevado de alguna manera a intentar generar ciertos marcos conceptuales de trabajo donde, digamos así, sin dejar de perder la rigurosidad o la precisión de las disciplinas, se vayan generando caminos hacia puentes o conceptos comunes que nos permitan construir un mismo lenguaje para abordar un problema. Y en ese sentido, bueno, es donde empieza nuestro gran debate y nuestro gran desafío de avanzar hacia una transdisciplinariedad, o sea, hacia conocimientos donde se fomenten estas habilidades que profundicen en pensamientos sistémicos, que profundicen la innovación colaborativa y profundicen la diversidad tanto de conocimientos como de valores, ¿sí? Entonces, en la educación de los ingenieros, este tipo de reflexiones, este tipo de trabajo que estamos realizando, creemos que impulsa la formación de estos profesionales creativos, que, con pensamientos sistémicos y a la vez flexibles y sobre todo éticamente responsables y que sean capaces de alguna manera de dialogar con otras disciplinas y sectores para desarrollar estas respuestas a, digamos así, estas respuestas complejas a los problemas complejos que se nos presentan. La siguiente, por favor. Y en ese sentido, bueno, las competencias básicas para ingenieros que hemos ido de alguna manera trabajando y tratando de plasmar en nuestros trabajos, eh, tiene que ver un poco con la necesidad que estos futuros y estas futuras profesionales cuenten con un sólido dominio en temas relacionados al cambio climático, a la economía circular, tecnologías digitales, o sea, y también en tecnologías digitales incluye la inteligencia artificial, y sobre todo también el desarrollo de metodologías sostenibles, ¿sí? También es imprescindible desarrollar, por otro lado, ciertas habilidades analíticas a los y las estudiantes, habilidades en el sentido de promoverles el pensamiento crítico, como ya les mencioné anteriormente, la colaboración interdisciplinaria o transdisciplinaria, y finalmente que ellos intenten tener una comunicación efectiva, ¿sí? Una comunicación efectiva en torno a mentalidades abiertas, al sentido ético y la responsabilidad social en torno a los problemas comunes que se nos generan, ¿sí? Y que de alguna manera la ingeniería puede aportar soluciones viables o en torno a, bueno, a estos temas que tanto se discuten respecto a soluciones basadas en la naturaleza, ¿sí? Entonces, de alguna manera, esta formación integral que buscamos y queremos plasmar en nuestros futuros estudiantes tiene que ver con esta idea de que ellos también sean los futuros líderes de esta transformación hacia sistemas más sostenibles. Eh, la próxima, por favor. Bueno, y en ese sentido, ahora quiero presentarles una primera experiencia que trabajamos, que tiene que ver con el programa de riesgo sísmico, ¿sí? Eh, el programa de riesgo sísmico surge luego de, bueno, luego de una reestructuración del Departamento de Geofísica de la Facultad de Ingeniería y donde de alguna manera se divide el centro sismológico. Chile tenía un centro sismológico que estaba funcionando de manera profesional, pero era muy técnico, entonces se genera una división para empezar a crear profesionales relacionados a los problemas del riesgo sísmico, pero que también tengan esta aproximación interdisciplinaria, sobre todo para la gestión de riesgo de desastres, particularmente terremotos y tsunamis. Entonces, a partir del año 2014, que se viene trabajando esta iniciativa, eh, el programa de riesgo sísmico ha ido incorporando profesionales y estudiantes provenientes de ingeniería civil, de geología, ciencia de datos, eh, las ciencias políticas, el derecho y sociología. Entonces, de alguna manera, este programa busca evidenciar cómo estas competencias básicas y ciertos enfoques colaborativos permiten enfrentar estos retos complejos a través de la incorporación de los objetivos de desarrollo sostenible en el trabajo que realiza, ¿sí? De alguna manera busca a través de ello incorporar o más bien mostrar un modelo donde academia y sociedad puedan trabajar conjuntamente en la prevención, en la preparación y en la mitigación de desastres en torno a las problemáticas del problema de riesgo sísmico, que como les mencioné son los terremotos y los tsunamis. La siguiente, por favor. Una segunda experiencia, y esta es un poco más nueva, es esta certificación complementaria en inter y transdisciplina para los estudiantes de pregrado de la universidad. En términos generales, este programa responde también a la necesidad de formar ingenieras e ingenieros capaces de abordar desafíos complejos, pero para ello también tenemos que enseñarles cómo se abordan estos problemas. Entonces, esta certificación, de alguna manera, lo que hace es eh, enseñarles metodologías de investigación interdisciplinarias y transdisciplinarias para que los estudiantes puedan generar estas habilidades colaborativas y ellos puedan comprender las metodologías participativas, ¿sí? Que promuevan este trabajo en equipo con personas, con estudiantes y otros profesionales de disciplinas distintas. También esta certificación integra esta reflexión ética y sobre todo una responsabilidad socioambiental en el abordaje de los problemas. Y bueno, como ya les mencioné, la certificación contribuye o busca que nuestras ingenieras e ingenieros sean capaces de entender y generar estas soluciones creativas y sostenibles alineadas con los objetivos de desarrollo sostenible. La siguiente, por favor. Finalmente, la tercera experiencia que quería contarles es sobre la red de pobreza energética. Eh, la red de pobreza energética es un espacio interdisciplinario con intenciones de ser transdisciplinario que vincula a académicos, comunidades locales, sector privado y sectores gubernamentales, donde de alguna manera busca generar los espacios para la discusión del problema de la pobreza energética a través de soluciones inclusivas que consideren estos factores sociales, económicos, ambientales y sobre todo factores políticos e institucionales que puedan de alguna manera ser los elementos que por un lado, nos hagan reflexionar respecto a los desafíos que tenemos y por otro lado, sean los ejemplos necesarios para pensar las soluciones a estos problemas. Entonces, este espacio de colaboración y diálogo, que ya está articulada de manera permanente, busca generar este foro público donde se promuevan estas soluciones y bueno, en términos generales les puedo contar que ha sido bastante exitoso en el sentido de que muchas de los documentos y recomendaciones que han salido de esta red han sido tomados en ciertas políticas públicas y documentos oficiales del Ministerio de Energía. La siguiente, por favor. Entonces, finalmente, para concluir esto, contarles un poco que desde la Universidad de Chile, la educación para nuestras futuras y futuros ingenieros está basado entonces en esta necesidad de integrar los objetivos de desarrollo sostenible, estos enfoques interdisciplinarios y transdisciplinarios, y además de desarrollar estas competencias básicas en torno a bases sólidas, por un lado, que bases sólidas en la formación de los estudiantes, pero a la vez mostrarles la complejidad que implica este problema. Entonces, finalmente, a través de estas experiencias, queremos mostrar cómo de alguna manera hemos trabajado eh, esta integración de los problemas complejos y quizás ver cuál es el impacto real de estos enfoques eh, en el trabajo con las comunidades y con los tomadores de decisiones. Así que, bueno, muchísimas gracias.
Thank you, thank you so much, Julian, and that works out fine. And it was, yeah, it was great to see all the different things that are being done in Chile. And it's great to see that universities are really trying to tackle this really complex problem, and it's great to see that we could actually hear it from you in your own words. That's a big advantage of AI, right? Let's just like this is great. Thank you so much. There's time maybe for one or two questions. I know like we want to break out and start talking to everyone in the room, but I do want to give an opportunity maybe to ask a question to one of the presenters, either Julian or Jonathan, if anyone has got any or comment. Maybe I'll just make a comment. Both of you mentioned the SDGs, right, as a framework, to just maybe anchor the type of transformation that we want to make. I mean, and then maybe on Jonathan, one question for you and one for Julian. For you, Jonathan, it's like the global responsibility. I just I like to ask. I like this because I think engineering is a deeply ethical profession. I just wanted to ask how much your resource, Global Compass, is being used, and who's mostly using it in your, since you launched it.
Yeah, it's a great question. And on the sustainable development goals point as well, we've featured that within the compass as well. I think it's the competency, social and ecological well-being, like building that awareness and deep understanding of those systems, as well as the sustainable development goals, is that important blueprint for progress. In terms of who uses the compass, we have a range of people who use it. So in the practitioner side in industry, we know and have worked with and have conversations with several engineering organizations who use it as a way to onboard graduates, for example, a way to kind of explore what their professional development means for them. And we have done introduction sessions with engineering organizations as well to help walk them through that. But those organizations that have sustainability, have social and ecological well-being at the kind of forefront of their mission and values as an organization is where we see really good use of the compass. And we're constantly working with industry to help do that. And that's where the professional engineering institutions and the engineering council, like the endorsement helps build more awareness, but also build more credibility as well in terms of like rooting that into this is relevant for your CPD. And it goes from bringing sustainability, ethics, engineering society as a tick box exercise to something a lot more deeper to place importance on that within how engineers are being developed. We also have it being used in higher education. There's several universities who are involved in our Engineering for People Design Challenge who have used the compass as a way to frame the learning outcomes that they have for their modules and for their programs as well. So there's a really nice coherent learning journey from students being exposed to global responsibility in their education early on, that continuing through their degree and then coming out into industry and being exposed to global responsibility again. It just adds that value of like we are now placing this more and more importantly at the center of our profession.
Thank you. That's great to hear. I hope, hopefully it's being used more and more and by all sorts of different settings and contexts. And then Julian, maybe quickly for you, it's a difficult question, so it's okay if you answer in Spanish. But I was you mentioned a few times creativity and creative thinking, right? Or yeah, creativity and engineering, do you think that's possible? Creative engineering. I don't know. How do you teach creativity? Can creativity be taught? I don't know. It's a very difficult question. You can answer in Spanish. Any thoughts?
Okay, thank you, Sabrina. Yes, it's a very difficult question. Bueno, en todos estos años que he trabajado aquí en la Facultad de Ingeniería, creo que he podido corroborar que la creatividad no es exclusiva de las ciencias sociales o de las artes. Yo creo que he tenido muchas estudiantes muy creativas en la generación de soluciones técnicas para ciertos problemas específicos en torno a, bueno, como les contaba, a estos problemas complejos. Em, en ese sentido, creo que la creatividad se refleja en la ingeniería en otros aspectos. Se refleja en la posibilidad de poder generar las condiciones técnicas o, digamos, sí, condiciones estructurales o, dependiendo del área de la ingeniería que uno se encuentre, generar esas condiciones que permitan dar esas respuestas adecuadas a ciertos problemas que se presentan quizás en el día a día. Te doy un ejemplo concreto. Durante los aluviones en Chile del año 2017, en el norte, la ciudad de Diego de Almagro fue arrasada por el agua, por el barro, bueno, por las lluvias en general. Y bueno, todas las líneas eléctricas, toda la conexión eléctrica se cayó y fue destruida. Entonces hubo un grupo aquí en la Universidad de Chile, por un lado el Centro de Energía y la Red de Pobreza Energética, que generaron pequeñas pilas o baterías construyendo a través de, digamos así, instrumentos con Arduino y o sea, generaron dispositivos para enviar al norte a esta ciudad que se encontraba a oscuras y enviaron para que de alguna manera tuviesen electricidad para cargar el teléfono y no estuviesen aislados o tuviesen algún tipo de luz durante la noche. Entonces, como te decía, la creatividad en la ingeniería quizás va de la mano con la innovación, pero también esa innovación necesita además ser una innovación con impacto social. Y yo creo que eso es lo que de alguna manera buscamos en esta facultad y buscamos que nuestros estudiantes entiendan.
Thank you, Julian. That's a lovely example. Thank you. Thank you so much. I know we got two more questions, but I hope that we can maybe take them in the breakouts because we want to give opportunity to people coming together. So we are going to now, I know, Julian, you need to leave. So some of the questions are, if you don't mind, we will send you by emails and then we can just get your thoughts that way. If we cannot, I know you need to go teach. Teach your students are waiting for you. So we're now breaking out in two different groups. So you will be sent to different rooms and we will have more of similar questions, but then the opportunity to discuss them as a group. So skills, competencies, mindsets. Examples of emerging topic areas that are being implemented, and then challenges that are, some of the challenges are being raised now in the questions in the chat, trade-offs, and how do we actually do it? And then what kind of support is needed? So there are resources that are out there, some of the ones presented by Jonathan, others exist and will be presented in subsequent webinars, but what kind of support is most helpful to actually encourage the uptake of these competencies? So let's just go back into our breakouts, and we will get back together and discuss in about 20 minutes time. Hi, welcome back. As usual, I wish there was more time for the breakouts, so maybe that's something for us to bear in mind for next time, because there's always more to discuss than we got time for. So, and sorry, Ivan, we just cut you there when we asked you a good question about creativity, creative thinking. I don't know if you
Sorry.
want to just share. Okay. All right. So we got just a few minutes left, and we wanted to just get a flavor for the discussion in the room, in the different rooms. Can I invite maybe Gemma from our room to just give us a bit of a quick recap of what we discussed?
Yeah, thanks, Avina. So I'm sharing our whiteboard here. I hope you can see that.
Yeah.
We spoke a lot about the different mindsets that are needed, about solutions not just being engineering, but actually being social solutions that with a technical component, and the importance of integrating social sciences into engineering practice and into solutions. You can see on the whiteboard here a couple of topics like circular economy, ecology, economic analysis. These are all kind of skills that will be important for future engineers. Having a long-term mindset and systems thinking, taking into account future generations, and the mindset of being in balance with the planet as well. And then in terms of resources and support, we spoke about practical experience that brings in multiple disciplines. We spoke about the fact that students need tools to enable them to implement these kinds of changes for sustainable development, and communications and frameworks that enable them to dive deeper. And we spoke again about systems thinking, and also brought in some elements of the SDGs and how they go about considering them. Is there anything that anyone wanted to add from our breakout?
That's good. I think, the only thing I would add probably is the SDGs, how engineers feel that they contribute directly to SDGs. They generally do not think they can have big contribution to poverty and social justice and other SDGs that are not immediately related to the built environment, but they need to become actually a lot more prominent in the engineering sort of mindsets and thinking. So that's probably something else that we added. Other group, who's going to be quickly summarizing the discussion?
Sorry, I'm here. I'm going to summarize our discussion in the second group. So here our speakers acknowledge the need to change the curriculum in terms of bringing complexity into it, but it also brings some challenges. So the engineering curriculum is already very packed with the key competencies. So balancing it with the transdisciplinary knowledge that is needed, it's kind of challenging. The need for challenge-based learning was emphasized in the group, as current 21st century problems are complex. So the solutions and the learning curves should be as complex, and students have to experience how to work in diverse groups and with different disciplines included. We also acknowledged the need to include different topics into the curriculum, such as ecology, And these, if you see in the green post, it's disaster management, digital twins, and carbon accounting and sustainability as a main framework to frame all these topics together. And in terms of required solutions and resources, we talked about the need for realistic case studies, and also acknowledged that there are good toolkits out there that educators can use already. So not everything has to be developed from scratch, and also the need for grants to educators. So educators need the time to develop such new curriculums, and we heard a good example from the University of Eindhoven, who give grants to educators to develop new curriculums. And if somebody would like to say something, Sarah or Jonathan or Tommaso, who spoke a lot in our group, just please add your thoughts.
I think silence means that you've done a good job, right, Regina? And also we ran out of time, so I don't want to take any more advantage of your time today, but I really like to thank you. This group is really great. We've done quite a few of these learning hubs, and seeing everyone engaged is really, rewarding for us. And thank you for staying with us until now. We look forward to seeing you next time. In a couple of weeks, we're going to be talking about how this has been integrated in curriculum. We have a speaker from an Engineering for One Planet framework. This is a well-known resource, particularly in the US. So just join us to hear from her. But also, I can't remember the other presenter, but we will advertise this. We will send a feedback form. Please give us feedback, because we are continuously learning. I guess if we want to make these sessions better, we want your suggestions, and I look forward to seeing you next time. Thank you. See you soon. Bye.